Hello and welcome back to Creators Chat. This is our after show convo. I'm Rusty.
I'm Peter.
Join us as we pick up on our conversation between Peter and Dr. Pollack and chat about who knows what. Streaming from Retro Earth Studio and brought to you by wearehistorically.com, Conscious Brand Apparel, and
Learn to play jazz piano like a pro. Buy a pro with Jazz Piano Pro Essentials at jazzpianopro.com.
Everybody, meet Dr. Pollack.
There's so many properties of this easy water that really haven't been fully explored. And I'm curious because this is kind of like the fringe, challenging a lot of paradigms of the general academia. Have you had pushback in your experience of really trying to get this information out there?
Oh yeah, absolutely.
Yeah.
It's as though I'm living on two different planets, and it sounds somewhat preposterous that there's a fourth phase of water. Some non-scientists have acted kind of reflexively, saying, "Oh, this is the weirdest thing I ever saw," without any substantive comment. Therefore, it must be wrong. But I think that for the most part, the scientific community has adopted a wait-and-see attitude, and waiting to see what the other guy thinks because they don't want to defect from the establishment. And there's a tendency that has existed throughout the course of science, whenever there's a radical point of view that develops. Scientists are conservative that way. They're reluctant to accept it. And one of the reasons for their reluctance, it could be that it's wrong. And another one could be that, it steps on the toes of those scientists. So if you believe in flat Earth and someone comes around and says, "Hey, I've seen some satellite photos," just the other day, including the other day, Richard Branson and such, and it looks round, it looks spherical. So, I'm thinking it's curved. It's not flat. What happens is that you can't get money to study this further because the people who are assigned to review your application for funding are the flat Earth people, and they don't want to be displaced because if you've earned your reputation, you, Peter, as a flat Earth guy, and some radical comes along and says, "Well, Peter, I'm sorry, you've devoted your life to it, but look at this evidence. I think you're wrong." And of course, you want to protect your turf. We're all human, and we don't like to be disgraced in this way because you've developed your reputation, and when the New York Times comes and wants to interview somebody about the shape of the Earth, they're going to come to you, Peter. They're going to say, "Hey, tell us some more about the little bumps that exist and depressions and such on the flat Earth." And you're the guy they'll come to. But if the Earth is round, you're going to say, "Forget it, Peter. You're outdated. We're going to go to this radical guy who comes with the new evidence." So anyway, we'd like to hang on to our turf. It's human nature, and so ideas that seem radical at first. Even Einstein, in the year 1905, he came forth with three new paradigms that changed the world. There was relativity, there was the photoelectric effect, and what was the third one? Brownian motion. And, relativity, it took 15 years or 16 years until Einstein won a Nobel Prize for the photoelectric effect that people began, or the physicists began believing about relativity, which stands for the they wouldn't, it seemed preposterous how the ones who could understand it, this is ridiculous. And And then Einstein became a kind of hero because he won a Nobel Prize. Oh yeah, of course, you're right. And so it's not only that, but in anything that. So okay, I talked to you about resistance and reasons that go beyond mere evidence or logic or arguments. I'm not suggesting that every piece of criticism that's come is necessarily erroneous. Some of it is reasonable. As one of my students said, it's like arguing that a branch on a tree is rotten and therefore the whole tree is dead, or something like this. You know,
throw the baby out with the bathwater.
Baby with the bathwater. Exactly. That's it. That's even better. But on the other side, I've talked about one side is the enormous, really enormous interest and pretty much acceptance by communities of people ranging all over the place, from people dealing with how to improve ice skating rinks to make the ice surface smoother. We have very frequent conversation, and he's writing a book that includes it. To health, of course, because if the cells are filled with easy water, fourth phase water instead of liquid water, everything changes. All of physiology changes.
Oh yeah.
All of health changes. To someone who's now written papers about how the Romans would cool themselves using water on ceramics and invoking easy water as the central mechanism involved with this. To what makes weather. There's so much that follows from it, and so many people from have taken up this idea of fourth phase water and used it in their particular realm. And so it's extremely gratifying to the point where it's really difficult to get work done because I get so many emails each day. And as I mentioned earlier, the enthusiasm over that later book, The Fourth Phase of Water, for example, on Amazon, is amazing. I feel so gratified by it. That I can't tell you how exciting it is for me.
Of course.
That's a long answer to your short question.
It's okay. No, it's one of those things where it's like I think one of the things that, obviously like Western science and Western world is this, needs to be quantifiable. And you've done that with relatively simple equipment. And that's one of the things that is pretty fascinating to me is that at what level could almost the individual small scale scientists do their own experiments on this?
Well, they can. Yeah, again, it's really easy. And in the fourth phase book, I describe how they can do it, how they can detect easy water in like 5 easy steps. All you need is, you need a Petri dish, some water, or actually any kind of water, a dye, which gets excluded from the exclusion zone or easy or fourth phase water. So you can look at where the dye isn't, very simple dye, and a magnifying glass, and you can do it yourself. It's really easy. Cool.
Yeah. And it's that aspect of kind of reinvigorating the natural curiosity that we kind of lose through the indoctrination process that I've found has been pretty interesting, just because I do my own experiments with water, and one of them that I've been doing lately is charging it in the sun in a glass vessel, and then I'll do some type of like prayer or mantra, and then before that I'll put it into a copper vessel to let it rest overnight. Again, another round of prayer and mantra. And I do blind experiments with friends that come over, and they've noticed observable differences within the water. It's more viscous. It tastes, as they say, it tastes better. It tastes like more like this water tastes like what water. Yeah. It has that kind of velvety, silky taste.
Yeah, exactly. Velvety. Yeah. Well,
that's
interesting. Yeah. Well, I hope you actually publish your your experiments if you are doing them in a scientific manner, which
Oh yeah.
I expect you are, because the world needs to know about this. I've heard the same from so many people. Even, well, um, uh, people who, you take 2 glasses of wine, and you say loving things to one glass, same wine, and hateful things to another. Just think them, and the two they taste differently. I'm really. It works. You should try it. Just
Okay.
pour from the bottle of wine. Pour two, and this is. Uh, uh, I learned this from a 3-star Michelin chef. His name is Heston Blumenthal, and we became friends. He invited me to his home in the south of France, and he runs a restaurant called what's it called? I apologize. It's called. Anyway, it's west of London. The Fat Duck, and the Fat Duck was voted by some group, I don't know which group, as the best restaurant in the world one year. So this is a rather distinguished chef, and knows what he's doing. And it was great to spend a day with him and sleep at his wonderful place in Provence. And we had a great time together talking science, because his interest is really deeply in science. And we also met at our annual water conference in Frankfurt, the one that I organized.
Wow.
And he took me out to dinner with a few of his colleagues. We had a nice dinner, and the first thing he started with, he poured the wine, and it was probably not the kind of wine that he serves at his restaurant, but Fat Duck is special. But he poured 2 glasses, and he told me, think positive thoughts on this one, and drink it, and then think negative thoughts on this one, and drink it. You notice the difference? The difference was absolutely clear. And so I think it might actually work with your water that's been sitting in the copper, because it probably contains a lot of 4th phase or easy water. That's where the information is stored. And my guess is that if you do the same sort of experiment, you might find a similar result. I'm not sure, but it's certainly worth trying. So there you go.
Yeah. Hey, more
consciousness
motivation.
Important, and as I said, my prediction is this is in the future going to be a frontier scientific issue, because it's becoming more and more important.
Oh, 100%. And that's, I truly do see this as the infancy of the study of water, because this is groundbreaking, textbook changing information that should be known more. And I think, we always have these subtle experiences and just even early lab work. We're doing dissections, looking under the microscope, and you see that these, on the cellular level, it's different. It is the liquid and the mediums that we would use to dissect things is definitely regular distilled water, but inside the cell, it's different. It's 100% different.
Yeah.
To the point where it won't mix even. So it's like, wait, what?
Yeah, it's 100% different. Absolutely. And, if you, we used to do a lot of experiments with cells, especially muscle cells. And if you cut the muscle cell, if it's really water that's inside, the water will come pouring out, but it doesn't come pouring out. Or if you cut yourself, the water should come pouring out, but it doesn't. It sticks. It's inside. It sticks to the solid surfaces. It's a different kind of water. It's easy water or 4th phase water.
Wow. Well, just in terms of the potential, technologies that could be developed from this, have you guys done different experiments in terms of getting energy from the water?
Yes, we have. So I mentioned early on that the easy water is negatively charged. And So, but you start with water molecules, which are neutral, so you can't get something from nothing. You can't get negative charge from neutrality. There has got to be a positive charge somewhere. And we found that if you have some hydrophilic water-loving surface, and the fourth phase or EZ grows next to it, it's going to be negatively charged. And what happens is the positive charges get pushed out beyond it. So you've got negative charge at EZ and positive charge next to it. It's like the two poles of a battery, the negative, the positive, kept separate, and kept separate by the energy that's coming in, the infrared energy that's coming in from the environment. So in theory, you've got a battery, and if you put two electrodes in, one in the negative, one in the positive, you ought to be able to light a light bulb. And we've demonstrated that. It works. What more can I say? Well, there's a lot more to say, because as various entrepreneurs know, and I'm not one of those, science is my passion, not entrepreneurship. On the other hand, I was persuaded to enter into some development with a company to try to bring this, but going from a laboratory demonstration to something that's practical and useful. Imagine, getting energy from the sun just using water. We do it all the time in our bodies, essentially, but to do it, requires crossing the so-called valley of death. And, a lot of ideas that begin in a laboratory have to pass across this valley to get to practical utilization. And the valley is very deep, and a lot of stuff winds up there. Whether this will wind up there, I can't say, but we're very much interested in creating something practical. It's not just getting energy from water and light, which, in theory is a no-brainer, but getting it to work in a practical sense is a real challenge. It needs investment, which needs money and such, but also filtration. The water we're talking about excludes practically everything. It's a crystal. And when crystals form, like ice crystals, you see at the bottom of a glacier, the ice crystals that have formed push out all the stuff, and you find all the junk, the glacial moraine at the foot of the glacier that's been pushed out as the water became ice, as the water became a crystal. So as the water becomes EZ, same thing happens, it pushes stuff out. So if you have input water that contains all kinds of junk, and it goes through this system that takes that water and builds EZ water, it pushes out all the junk. You collect the EZ water, and you have a junk-free kind of water. So it's a filter, but it's a so-called filterless filter because there's no physical filter involved. It just involves the separation, the creation of EZ water from ordinary water, a process of which eliminates or pushes out the contaminants. One of the contaminants could easily be salt. It's not a contaminant, but imagine you put in ocean water, and the energy required to do all this stuff is from the sun. You've got lots of sun in the place where you need drinking water. You take the ocean water, you put it in, you got the sun, builds EZ water, and out comes water that's free of salt. You can drink. We're working on that too. But these are radical developments. They might or might not succeed. I'm hopeful that they will succeed, but they need investment. So it's not just from the scientific point of view, but there are practical outcomes that might work. We're still not sure, to bring to practical fruition, which could solve some of the most important problems that the world faces today.
Oh, 100%. And with that light, what is some of the most potentially interesting avenues of development that you're personally like excited about, that if this works, this is a game changer?
Well, getting electricity, uh, we're we're so short of. We use actually such a small percentage of the sun's energy for, shall we say, useful technological purposes, and if we feel really constrained to depend on technology in the future, rather than going back to the ancients and living off the grid and such, we need energy, and we can't depend on fossil fuels in the future because they run out.
Yeah.
We need something that's renewable, and this is absolutely renewable. As long as the sun shines, we have that energy that's coming in. A lot of people don't realize that something like half of the energy of the sun is not a visible light, but infrared light, the heat that we feel from the sun, and we can harness that. We can harness that energy, that infrared energy, to do something that was thought previously couldn't be done. But in principle, it can be done, and it's just a matter of doing it, of putting the resources together and taking the gamble that it can be done. And if it is done in a practical way, it could be amazing for the world.
Oh, it's 100%.
Yeah, it's not only that, but also using the sun's energy for health. We all have a feeling, especially those of us who live in Seattle, including you and me. We don't see the sun so often in the winter, and we go out, and one day in December, the sun peeks its shiny face out. We all feel good, and we wonder, is this some kind of subtle psychological effect, which it could be. It could also be that the infrared energy that's coming from the sun penetrates into our body, our head, and restores the EZ that's in every cell in our brain into the level, the default level, which is those cells are filled with easy water, and the brain cells work the way they ought to be working, which is the default state of feeling good instead of feeling down or depressed. You need that sun. It could work in a way that I'm suggesting. We don't know that it works that way, but it's a simple hypothesis that doesn't rely on anything exotic. And so that's have you had the experience of going into a sauna or using that at all?
Yeah.
Yeah. I have to, especially in Finland and Russia, where they do it all the time. They know what's good. It's the same thing. You're exposing yourself to infrared energy, to heat, and that heat penetrates, especially when you don't have clothing on, although it penetrates anyway. Every cell in your body gets infrared exposure, and it's no surprise that you come out feeling better than you come in, because that energy should build easy water and should build it in all of our cells. The cells should function better, and we feel better. So no surprise about that. Yeah.
That's interesting to think about in terms of like the health industry. And I'm almost even looking at, different materials that they use for, patching up surgeries, different types of sutures, and the incorporation of easy water, and trying to be almost like in terms of the filtration of getting rid of contaminants. I'm almost curious to see if there's these antibacterial, microbial properties of it that they could somehow try to integrate in hospitals.
Well, I hadn't thought about that a whole lot, but I think it's possible because, the easy water, as it grows, it pushes out. We have experiments that show it excludes bacteria and viruses and such. So yeah, I mean, you could be onto something really important that we have yet to pursue.
Well, it's even the combination of it. So I was more so coming at it from the angle internally of, okay, well, how could we enable people to produce easy water within their system faster if it does have this key component to physical health? Because this is the thing that I'm very curious about, where it's like this changes the way we look at disease. if we actually were to look at how we could physically test someone's levels of easy water. Now that's a different story.
Well, yeah. So we have a way. We have a way. It needs development, and that is, it's just two simple steps. Um, and I can't give you the evidence to convince you. Number one, on the elevator pitch sort of thing. Number one, your cells are filled with easy water.
Yeah.
Number two, easy water is negatively charged.
Mm.
Number three, all your cells are negatively charged. Number four, it doesn't take a rocket scientist to figure out if your cells are filled with water and the water is negatively charged, your cells are going to be negatively charged, right? And the more easy water you have in your cells, the more there should be negative charge. Now, this is not a widely accepted view at all. What I'm telling you about. If you read any biology textbook, they'll give you a different interpretation of why the cells are negatively charged. It has to do with membrane pumps and channels. And I've in the two books that I mentioned, The Fourth Phase of Water and Cells, Gels, and the Engines of Life, I argue to attempt to dispel those notions. I think they're wrong and illogical. I'm sorry to be blunt. A simpler argument is the reason that the cells are negatively charged is they're filled with water, easy water that has negative charge. So if your cells have a lot of easy water, they'll have a lot of negative charge, which means if your body has a lot of easy water, your body's going to have a lot of negative charge. Right? Mm-hmm. So if you could measure the negative charge on your body, in your body, you'd have a measure, a sort of general measure of health, because this easy water is critical for health. And people have actually measured the negative charge or negative potential of cells. And cancer cells, for example, instead of negative 60 or 70 millivolts, it's negative 10 or 15 millivolts only, suggesting that the cancer cells are missing a lot of easy water. And it fits some other evidence. The same with pathological kidney cells. Same, 15, 20 millivolts negative instead of 60 or 70 for healthy kidney cells. So I think there's some evidence to back this up. So what I'm getting to end the elevator pitch, is if you could measure the electrical potential of your body, it may be possible to tell if you're generally healthy or not so healthy, just by that measure. And we started doing that. Actually, some students tried to make measurements as part of classroom exercise. And of course, as a classroom exercise, the results were all over the place. But some of the more reliable ones done by some of the more gifted students indeed showed that the body has a negative electrical potential that could be measured. So this requires some development, but it could be, in the future, it could be a diagnostic measure to use to assess the health of someone, probably in an extremely simple way. It could be a gadget that you buy for $10 on Amazon.
Hold on to the cat, though. See how
yeah,
you do.
Right. Something just like that, and check your health. It could be a diagnostic that then leads to further diagnostics to figure out if you're not fully charged, so to speak, what's wrong with you. So I like that. That's exciting too. Yeah.
Oh yeah. I mean, that's the cool thing, because to me, it just even goes into, it's like, the human body has the negative energy potential. We know that Earth has this kind of almost negative energy potential as well. Yes. What's the correlation between the two? Is there a difference in the frequencies and vibrations that we emit? Like, my mind just goes to so many different avenues of exploration.
There's a lot to be learned. We've really just scratched the surface. It's coming, because lots of people are getting interested. Lots of people are doing experiments, and with with new views toward how nature works.
Yeah. Ooh, even
It's
just a
not.
simple.
Yeah, I mean, it's not just that. I've got two books coming on
Oh.
subjects that you might say build to some extent, and they're, I'm not sure how to put it, maybe even more radical, you might say, about how nature works. And they're all based on logic and evidence. And my late wife told me to avoid writing more controversial books because the water stuff is controversial enough, and it seems to have done pretty well. Just stick with it. Don't risk your reputation. But it's for me, it's the ultimate curiosity and search for truth. How does nature work, particularly in this environment where there are so many mistruths and disinformation and such.
Yeah.
Trying to use simple logical thinking and simple experiments that anybody could do at home, like your experiments with your copper vessel, needs to be done, and more people need to get into it, because ultimately, what is science? You have an observation, and the scientists need to pay attention to the observations and search for the explanations, not dismiss them as some. I hesitate to say many. Some scientists will do. Oh yeah, if it's true, someone would have discovered it 50 years ago, so it can't be true. Or everybody knows that X, Y is true, so why bother dealing with your crazy ideas? Unfortunately, and in the kind of environment that we are today, where disinformation gets the same audience as information, we sometimes have trouble distinguishing between the two. It becomes more difficult for science to make inroads and to create scientific revolutions. We have plenty of technological revolutions, like what's enabling us to communicate right at the moment. But there are very few scientific revolutions. If you try to count on how many there are that are of the same magnitude as, I don't know, the splitting of the atom or the genetic code, those are all 60, 70 years ago. It's really hard to find them. So science is, although there are lots of crossing the T's and dotting the I's, there are not many scientific revolutions. And I think it's because of the way science is working today.
100% agree.
Okay.
100% agree with that. Well, I mean, I've seen it kind of evolve even these past like 10, 15 years, especially, where it's turned into its own, obviously, like institution and establishment. And I see a lot of people that, unfortunately, we have a very large population, especially in America, where it's like we're science illiterate. So science has gotten turned and transformed into almost like a church-like figure, where if you question it, bad you. If you do this, bad you. You have to stay within your lane. And it comes back to what you were saying earlier, in similar sense of like the gatekeeping and like the kind of academic competition. There's been it's just transformed, where it's really lost the harmony of maintaining that childlike curiosity to discover. And you can only discover new things when we enter into the unknown, but everyone just keeps wanting to cling on to the old paradigms. But
it's human nature. We feel we feel secure that way,
And I know you mentioned it and we didn't get a chance to talk about it, but did you want to do any types of pitches or any types of information drops for the Institute of Venture Science?
Yes, I would. The Institute for Venture Science is an organization that's designed to bring truth. And how is that? Well, the Institute promotes ideas that challenge conventional ideas that have outlived their usefulness. And we do this by funding scientists who are brave enough to challenge convention. Many such scientists may be brave enough, but their ideas are rather how should I say, outlandish, or we vet those ideas very, very carefully, and we choose the ones that look from our review, which is a very extensive review, like they have a chance, if given an opportunity, to really shake the earth. And we do very careful vetting of applications that we receive. And we want to fund the most exciting ones that fall into that category. So we've already identified 5 particular areas out of 200 pre-proposals that eventually were weeded out to a smaller number of full proposals and such.
Wow.
And we're looking for support from people who have done well and would like to help promote the finding of scientific truth. There's just and if they would like to contact me, my email address is all over the internet. I'm really easy to find, or very simply, it's GHP, Gerald Harvey Pollack, GHP at IV Science, IV like intravenous, it's an Institute for Venture, ivscience.org. And we'd be happy to chat with you about this. Just one final point about this is there's a special tweak that I think will help ensure our success, and that is if you, Peter, are advocating a round Earth and everybody else thinks that the Earth is flat, even if you get money from our organization or another organization to pursue your ideas scientifically, to pay what's necessary to do experiments for you, you still won't make it. You won't create a revolution. And the reason why you won't is somebody's going to pop up, one of the flat Earth people, and they're going to say, oh, Peter Lucas, he's a crackpot. Pay no attention. And then what are you going to do? You raise a flag and say, no, I'm not a crackpot. You suddenly become controversial and people won't pay attention to you, et cetera, et cetera. So the way to get around that, which is a necessary condition, is if we fund you, we're going to fund up to a dozen other laboratories around the world who are independent of yours, who also think, the world might actually be, or the Earth might actually be round instead of flat. And then when you and your dozen other colleagues go to the annual meeting of the Shape of the Earth Society, and suddenly a dozen different groups are reporting that the Earth is round, it's not flat, they can't dismiss you as a crackpot. It won't work anymore because the evidence is so clear. Each scientist using a different method come up with the same result. They have to pay attention. And that will create very quickly scientific revolution. And that's what we're looking for. So we're looking for support. This is not something that governments, as you can imagine, will support, although it would be nice. But it is, I think, an absolute key for restoring science to the fruitful endeavor that it once was. So please don't hesitate to contact me, us, at the ivscience.org.
Oof. And with that, I will just say, everyone do their part. We're in this realm of history where you can be your own leader in this search for truth. And I think with that, we'll close here. And I just want to say thank you again so much, Dr. Pollack, for coming on the show. We're definitely going to have you on in the future. And with that, roll the outro.
That concludes this episode of Creatives Chat. Thank you for watching. Join us every Thursday at 3:33 p.m. Pacific Daily Time as creative minds get together and chat about who knows what. View more episodes on our YouTube channel. Don't forget to like and subscribe. Thanks again to our sponsors for making this show possible. Thank you, We Are Historically, for your conscious human apparel. Shop online at wearehistorically.com.
Hi, I'm Darius Wilrich. I'll teach you everything you need to know about playing jazz piano like a pro with my 12-week online video course and downloadable guidebook, Jazz Piano Pro Essentials. Enroll today at jazzpianopro.com.
Thank you for joining us. Have a happy always.